Hi, Algebra 2. This is Unit 11, Lesson 8, and today's lesson is about graphing sine and cosine, but this time we're going to look at the period and the frequency. So remember the other day in Lesson 7, we talked about equations like that had a coefficient in front. We referred to that as our A. What does the A represent? The A was my height. It was a vertical dilation, so I was like stretching it up or down. So it's a vertical dilation, the A. We're basically stretching or shrinking it. That was the height, okay? So it gives the range of the graph. Gives the range of the graph. So the amplitude is basically the height of the waves. And remember we said the amplitude is the absolute value of A. Today we're going to talk about a different coefficient, and that's going to be B. So the B in there is going to be stretching it horizontally or shrinking it, okay? So in this particular graph, you can see right there that B is equal to 1. There is no number in front. So the number in front of my X is just 1. That's a regular sine graph. That's one complete cycle happens between 0 and 2 pi. All right? Below, right here, I have the graphs for one cycle of y equals sine of 2x and y equals sine of 1/2. So in this particular one, B is 2. You can see when B is 2, I actually have 2 complete cycles. So I'm starting here, okay? So say here, I'm going to do this so you can see it. I have one complete cycle, happens between 0 and pi, and then I have a second cycle that happens between pi and 2 pi. So when B is 2, when I have that coefficient of 2, I have 2 cycles between 0 and 2 pi. And the next one on the right, B is 1/2. Well, when B is 1/2, between 0 and 2 pi, which would be a normal one cycle, I actually only have half a cycle. So I have half a cycle between 0 and 2 pi. I have to go from 0 to 4 pi to have a complete cycle. So as the value of B is changing, it's a horizontal dilation. You can either stretch it, like I did with y equals sine of 1/2 x, or you can shrink it, like I did with y equals sine of 2x. So the B is going to be affecting the horizontal dilation. Between 0 and 2 pi, how many cycles of a sine curve appear for each of the graphs? So in the regular graph, y equals sine of 1x, and I didn't have the 1 written there. B is 1, and there's one cycle from 0 to 2 pi. When y equals sine of 2x, B is 2, and there are 2 cycles from 0 to 2 pi. So that B, that frequency, is telling me how many cycles. And when y equals sine of 1/2 x, oops, I left out my x here, 1/2 x, B is 1/2, there was half a cycle from 0 to 2 pi. So we have a few more vocabulary words that we need to go over. So the parent function is at y equals sine of 1x. The parent functions for sine and cosine graphs all have a period of 2 pi. That's one cycle. Okay? By definition, the period of a sinusoidal curve is the length of one complete cycle or wave. So that's referred to as the period. The period of a sinusoidal curve is the length of one complete cycle. So we can see right here, one complete cycle for y equals sine of x on the left. The critical values are 0, 1, 0, -1, 0. And on the right, I have one cycle of cosine, y equals cosine of x. My critical values are -1, 0, -1, 0, and 1. So this gets a little bit trickier than the ones with the amplitude. All of these critical values have to occur between 0 and 2 pi. And all the critical values for cosine have to occur between 0 and 2 pi. So when I change the period, okay, when I have that b, that's going to change where those critical values are taking place on the graph. So if the value of b changes, then the number of cycles from 0 to 2 pi changes as well. Okay, so as b changes, the number of cycles are going to change. By definition, the frequency of a sinusoidal curve is the number of cycles from 0 to 2 pi. Okay, b is the frequency. So the frequency of a sinusoidal curve is the number of cycles from 0 to 2 pi. B is my frequency. Since sine and cosine functions have a period of 2 pi, the function y equals a sine of bx or y equals a cosine of bx completes one period as bx varies from 0 to 2 pi. So what does that really mean? To find the period of a sinusoidal curve, all you're going to do is divide 2 pi by the value of b. So the period is 2 pi divided by whatever b is. So that's important. So this is the length of one cycle. And I'll show you some pictures. So to find the period, you're going to do 2 pi divided by b. So if we look at this example 1 right here, all right, b is 2. I find the b value as the number in front of that x. So b is 2. That means my frequency is 2. I have 2 complete cycles between 0 and 2 pi. So here's one cycle, and here's a second cycle. I have 2 cycles between 0 and 2 pi. The period, remember the period is 2 pi divided by b. 2 pi over 2 is pi. So that means I have one cycle between 0 and pi. Let's look at this next one. So b is 1/2. So I got b is 1/2 right here. The period, or let's do the frequency. That means the frequency is just 1/2. So between 0 and 2 pi, which is a typical graph should be, that's the parent function, is one cycle. You're only going to have half a cycle between 0 and 2 pi. So you can see right here, I only have half a cycle when I get to 2 pi. I have one complete cycle between 0 and 4 pi. Well, that number is going to come from the period. Remember, the period is 2 pi divided by b, and 2 pi divided by 1/2. Remember, I have to flip this when I'm dividing and I have a fraction. I change to multiplication and flip that second fraction. So my period is actually 4 pi. So the period is how long it takes to have one complete cycle. So it's different than b and it's different than my frequency. Okay? My frequency, or my b, is what happens between 0 and 2 pi, because that's a normal cycle. In this particular case, I only have half of a cycle. My period is how long it takes to have one complete cycle. So tiny bit different. All right, so let's look at just a few examples. So I want to state the amplitude, the period, and the frequency of each of these graphs. I'll look at A and C. Okay, so A is 3, B is 1, because there's no number in front of that X. The amplitude is just the absolute value of 3, which is 3. The frequency is my B value, and my period is 2 pi over B. So my period is just 2 pi. I will have one complete cycle between 0 and 2 pi. The only thing that's changing here is my height. All right, let's look at C. A is 1/2, B is 3. So my amplitude is the absolute value of 1/2, which is 1/2. That's the height of my graph. The frequency is my B value. So I'm going to have 3 complete cycles between 0 and 2 pi. My period is 2 pi over b, 2 pi over 3. So 1 complete cycle happens between 0 and 2 pi over 3. The graphing is going to get a little bit trickier to do. Well, let's look at example 3. Determine the period. B is pi over 2. The period is 2 pi over b, so 2 pi over 2. Remember, when I am dividing, I change to multiplication and I flip that second fraction. All right, so my period is actually 4. I have 1 complete cycle between 0 and 4. All right, so state the amplitude, period, and frequency. Amplitude is going to be the easy one. Amplitude is just the height. So my highest point is at 2. Easy. My frequency is 1. My frequency is how many cycles do I have between 0 and 2 pi. So I have 1 cycle between 0 and 2 pi. My period is 2 pi over b. Well, that my frequency was just 1, so my period is just 2 pi. 1 cycle from 0 to 2 pi. So in this particular graph, I stretched it horizontally, but I did not stretch, I stretched it vertically, but not horizontally. So what would this be? This graph would be y equals negative 2 sine of x. I did not change the b, I changed the a value. Okay. Next one, amplitude. That's my height. That's the easy one. Amplitude is 1/2. It's a little bit shorter. My frequency is 2 because I have 2 cycles. Here's 1 cycle. Here's 2 cycles. I have 2 cycles from 0 to 2 pi. So that means my b is 2. The period is 2 pi over b, so my period is pi. I have 1 cycle from 0 to pi. So what would this look like? The amplitude is 1/2, that's my a value, and my b value is 2y, so it's y equals 1/2 sine of 2x, because remember I had a frequency of 2. Let's look at one that's a little bit stretched out. My amplitude is 2, because that's the height. By the way, this is a cosine graph, so let's keep that in mind when I go down to write it at the bottom. My frequency, okay, between 0 and 2 pi, I only have half of a graph, half of a cycle. So my frequency is 1/2. That's my b value. And I already knew that my a value was 2. They did want me to find the period, though. The period is 2 pi over b, and b happens to be 1/2, so my period is 4 pi. I have 1 complete cycle between 0 and 4 pi. So we got to keep that period in mind for when we go to graph them. All right, so when we're doing this, you have to identify the critical values. That's important. The critical values for sine and cosine. The critical values for sine are 0, 1, 0, -1, and 0. And the critical values for cosine are 1, 0, -1, 0, and 1. You have to multiply all of those critical values by a. Okay, that will give you the height. And you have to graph 1 cycle of the wave by using the value of the period and the key point. So all those critical values, 1 cycle, here's the important part, 1 cycle has to pass through all critical values. All right? And we'll just use whatever interval or directions they give us on how many cycles that I'm going to graph. I did this one, but I did change it, all right? So I changed this. Let's change this together. Y equals negative cosine of 2x, all right? So A is my height. It's the number in front. That's -1/2. B is 2, just to do something a little bit different. My critical values, this is a cosine graph, so my critical values of cosine are 1, 0, -1, 0, and 1. all of those have to get multiplied by my a. So my new critical values are -1, 0, 1, 0, and -1. Here's the thing though. B is 2, so we got to talk about my period. My period is how long it takes to have one complete cycle. My period is 2 pi over B. 2 pi over 2 equals pi. So I have one complete cycle between 0 and pi. So every single one of those 5 values have to occur between 0 and pi. So I have one cycle, gets a little bit trickier with the graphing, from 0 to pi. So all 5 values have to happen between 0 and pi. So when I go to graph this, and I know I'm going to do from 0 to 2 pi, so I'm going to make my graph like a little off center here. Okay, so, and this is going to be 1, this is going to be -1, just so I have a little bit more height to actually graph these. So, and let's see, so every other, I'm going to do every other. So all 5 of these values have to occur between 0 and pi. All right, so this is going to be my pi right there. And then I'm going to do, this will be my 2 pi. I'm graphing everything between 0 and pi. So I'm starting at -1, 0, +1, 0, -1. I see how I have one complete cycle between 0 and pi. And then I'm just going to continue with the curve. I don't have to think too much about it. And here is my second cycle. But there's one complete cycle between 0 and pi. Now, do I have to fill in all of these numbers in between? No, but it would be nice to have at least one more. So this is pi over 2. I mean, if I wanted to, this one would be pi over 4, but I don't need to put all those in there. Okay, this one right here would be 3 pi over 2. So we're used to the pi over 2, pi, 3 pi over 2, and 2 pi. You don't have to do more than that. That would be plenty. Okay, let's try this one right here. So I have graph one cycle of y equals 3 sine of pi over 2. So a is 3, b is 1/2. Okay, because there's a 1 in front of there. So this is the same thing as if I wrote y equals 3 sine of 1/2 theta. All right, my critical values are, this is a sine graph, 0, 1, 0, -1, 0. I have to multiply all my critical values by 3 because that is my amplitude. So my new critical values are 0, 3, 0, -3, and 0. And those critical values have to occur between 0 and, well, actually, I did this, but I forgot to write it over here. My period is 2 pi over b, so 2 pi over 1/2, which is 4 pi. So that means I need one complete cycle between one cycle from 0 to 4 pi. So when I go to graph this, and again, I'm going to make it like a little off center here. All right, and we'll just make this 3, and this will be -3 because that's my height, okay? So I've got 1, 2, 3, 4. So I have one complete cycle between 0 and 4 pi. So the halfway mark is going to be 2 pi. Half of the half is just pi, and in between here is just going to be 3 pi. But you don't need to label that. That would be fine. So here are my critical values, 0, 3, and I should probably do it in a different color. 0, 3, 0, -3, and 0. See how I have one complete cycle between 0 and 4 pi. So figure out your critical values, figure out how, what's the period of that, and then just label your graph accordingly. That's really just the bottom line, is putting those numbers on your graph accordingly. The next page is really just more of the same. Okay, so just make sure that you identify the key points, identify all the properties, graph one cycle of the wave by using the value of the period and the key points, and then whatever interval that they happen to tell you to use, then you're going to use that. All right.